this video, I will be talking about my Gadget design project in which I created an extendable binder. First, I'll go over the problem statement. Have you ever had to store many papers all in one binder? Usually the binder deforms or ends up breaking because of all the bulk. This also makes it deformed, causing it to be awkward to hold. What if you could adjust the binder to properly fit all your folders? This would stop the binder from deforming and make it more comfortable to hold. Design statement. Design, construct, and test a binder in which its spine can adjust to added bulk up to at least 450 sheets. This brings us to the criteria and constraints. It should be able to hold up to 450 sheets. It should use a 1.5-inch binder, which is vinyl. The top, when it's extended, should extend at least 1.5 inches more. The top cover should remain straight and shouldn't be deformed, so it should stay at a 180-degree angle. Constraints. The price should be $20. It shouldn't take more than 45 seconds to use, and the measurements of the binder itself should not have a height less than 11.75 inches, a width of 10.5 inches, and a spine of 1.5 inches. The functioning prototype must be able to be made within 1 week, which is when the project was due. The materials I used to build my prototype was the LostBot Mini 3D printer, Fusion 360, Cura LE, a 1.5-inch binder, string, a box cutter, and super glue. The procedure. First, design a 3D model of a slide, container, and clip. These will be the parts that work to extend the binder. Print at least 3 times. So these are the photos of the parts. Second step, download the parts as an STL file and print them out using a 3D printer. Third step, attach a piece of string to the clip and pull it back behind the container part. The string will act as a hinge. 4. Cut the top of the binder. Mark spots for where each extender will go, so on the spine and on the top. Step number 5. On the top where you made the markings, use a box cutter to make slight indents for the slider, then super glue the slides. This is to make it easier to glue. 6. Super glue the remaining parts on the spine where you made the markings. And yeah, just clip them back on. Going over the evaluation. Product reflection. Some improvements to the design could be how on my prototype the clip was attached using a string which acted like a hinge, but using an actual hinge would be more secure and efficient. Another improvement could be aesthetic appeal. The extenders could have all been printed using the same color. The binder itself could have been customized more with drawings. Product life cycle. The raw materials needed to be extracted for the binder would be paper waste, recycled steel, and plastic waste. The paper waste would need to be pulped and rolled into steam rollers. The steel and plastic need to be converted into liquid form and then poured into molds. Additionally, there would need to be a machine that assembles all the parts. It would use plastic packaging and would need transportation, like trucks, for the products to reach stores. Craft binders are durable and long-lasting, so the product can be used many times. Craft paper/cardboard is recyclable and biodegradable. Steel can also be recycled, and plastic as well is recyclable. Reflection. Overall, the product met its criteria and was able to function well. Finally, here's the ELA component, which consists of a short description of the product and a short story. Here is the description, and here's the short story of someone using the products. And this is the social studies component, which goes over the evolution of binders, starting from the early 19th century to the late 19th century, the early 20th century, and finally the mid-20th century.